Okay, so we can start. It's time. I think my screen is shared. And what about the audio? Uh, Ilham Mustafa, can you just confirm once that I'm audible or not? Hello? Mm, Ilham, can you hear me? I think I'm unmute. And, shared my audio also, so most likely I will be audible. I think Ilham is not responding. Mm, one second. Okay, okay, I'm audible. I saw the message. Okay, then we'll start. We waited for 5 minutes, so we can start now. So, the major topic for today's discussion is regarding the forecasting. So, uh, what we usually do is we'll just briefly recap what were the important concepts taught in the uh, content for this week's discussion, and then we solve some problems in between, and that's how it goes. So wherever I feel uh, some sort of concept is important to be introduced or discussed in detail, I'll do that. And wherever there are like some concepts are there which are uh, easier to understand, but the application of those concepts in various numericals or uh, various type of questions is a tricky thing. So there we'll take questions. So we'll start. So yeah. So first of all, uh, see, forecasting, as the name suggests. Uh, First of all, you should know the difference between forecasting versus predicting. So this is the basic uh, thing that you should know before going to solve anything or learn anything in this topic. So basically, forecasting is nothing but a scientific way of predicting a demand for a certain type of business, whereas prediction is, there is no scientific basis for it. In common language, you call gut feeling. You go with your gut feeling sometimes. That can be one of the prediction uh, motivation, or in some cases where the product is, or the industry or the factory or whatever it is, the entity, if that is quite newly established, then you don't have historical data, and you can't use the scientific methods that we are going to discuss in subsequent discussion. Since you don't have historical data, you can't use those methods, and therefore you need to rely on your uh, first of all gut feeling, and secondly maybe uh, experts, the people who are working in that domain for a longer period of time, who has seen enough variations in the industry dynamics. uh, those people can take a better guess, and that is actually prediction. But forecasting is a scientific method. We use different mathematical tools, etc. There will be obviously error, because the type of forecasting techniques that we are going to learn here are like deterministic for forecasting methods. For example, uh, in some of the averages method, what we do, we take the historical data of some previous time periods and take an average. Uh, you can take simple average, or you can take weighted average. We'll talk about them later. or you can do exponential smoothing and all. But whatever you predict, we predict here, like in this class of forecasting techniques, we predict the forecasting demand with 100% deterministic nature. But in reality, nothing is permanent or nothing is deterministic, everything is probabilistic. So there are certain types of forecasting methods which will give you prediction with certain probability, but I think that is out of the scope for this course at this level. Maybe in higher studies you may look into those, but we'll stick to the deterministic ones. And since we are predicting future demand with 100% probability, there will be obviously error in the prediction. And practically speaking, if you are going to use these deterministic forecasting methods, then you need to, your objective should be to have as much minimum deviation with your uh, forecast prediction versus actual demand when the time passes. So that's how you can keep track of your uh, accuracy of your forecasting techniques. And at certain point of time, if you feel these deterministic forecasting methods are enough for your predictions, they are quite accurate for your business setup, then you can stick to them. But if they are not not predicting properly, then there is a problem. Then you have to tweak them somehow, or maybe go for some higher this thing, uh, complicated probabilistic forecasting methods. But let's not go there. Uh, then yeah. So first of all, the methods that we are going to discuss here, they are, like as I told you, deterministic methods, and the primary reason for studying them is they are quite easy. They don't need difficult calculations or difficult uh, codes or anything. So, and one can easily relate with them from their uh, physical significance. We'll talk about them when we come there, but that is what the brief of this topic is. We use simple forecasting methods, but as every coin has two sides, when you use simple methods, there is a chance that your estimation can go wrong, and that is the risk that you take with these methods. And the overall objective should be, uh, you know, to have as much less deviation as possible between your forecast versus the actual demand that you realize. So that is the first thing. Now, this can be itself in one question. What is the difference between forecasting and prediction? I mean, there is one question that usually typically asked is, uh, uh, one second, I'll just make sure that I give you that question directly. Uh, yeah, so the typical, like this is one of the way to ask this question. Uh, the preferable method for forecasting demand for a new product is, you have options as quantitative technique, second you have qualitative technique, uh, then there is moving averages, and fourth is linear regression. So as I was saying, uh, when your product is new, you don't have enough historical data, and in that case you can't use much of the scientific methods that are available. So there what you do, uh, uh, what you like, you can't do any quantitative technical analysis. And again, moving averages and linear regressions are nothing but quantitative techniques only. So if you just know these two things, you can guess the correct answer, which is qualitative technique. And there are certain qualitative techniques such as, I mean, these were discussed in the class. I'll just uh, list them so that you'll be reminded of them once. So basically, there is something called as jury of executive opinion. So what they do, uh, they basically take help of different experts and their opinions, and they combine and take an executive call. Then there is something called as Delphi method. Uh, you may remember uh, this keyword Delphi method, because this can be one liner in GATE exam or any other competitive exam. At least you should know what this Delphi method means. It is a qualitative method in which you'll have a panel of experts, and there will be one moderator, and this moderator will conduct the discussion session, and they'll moderator will ask each and everybody, each of the experts about the their point of view, what forecast they are assuming or expecting, and then they'll this collaborate with other experts and make sure that all are on the same page, and then they arrive at the final conclusion for the forecast. And then there is one more method where you take the help of ground level sales force that your company is having. There, what you do, you instead of relying on experts, what you do, some you may be having some sales force in your company, or maybe some third party sales companies you can take help of, and just estimate what is the actual sales happening for your product on the ground level, how much demand it is in, and then accordingly you can do that estimation for different geographies, different demographics, and then you can arrive at an aggregate number of total demand for uh, uh, future, taking some correction factors into account. And there are some techniques like consumer market survey, etc. So those are also there, but more or less you get the idea, right? These are qualitative techniques. You will not have any mathematical formula as such. uh, you'll have to basically take a educated guess in these kind of things. Then there is one more question. I was just looking at it. Yeah. So basically, uh, first was what is forecasting. Now second is why. Why do we do forecasting? So that is the purpose of forecasting. So in short term, uh, forecasting will help you in taking decisions regarding production planning, uh, raw material planning, etc. So you get the idea, right? So basically, uh, uh, this raw material planning, let me be clear. I think I should not put it here, because if somebody sees it later, they may get the wrong idea. So basically, uh, uh, and by short term, I mean it actually varies with respect to industry. But when I say short term, uh, what I mean is, let's say time horizon of uh, maybe 3-4 months, and then what you do, uh, whatever targets that you have, uh, you break it down to the shift level. So let's say you have a quarterly target, then you break it down to the monthly target, and then you break it down to the weekly targets, and then on each day for each shift how much production you need to do. So that can be done only if you know the certain numbers which are being calculated using forecasting techniques. So this is for short term. Somebody may ask, then is this the only benefit? No. uh, you can do some medium term predictions also. So for example, this is what they call it as aggregated numbers. So aggregated estimates, you can say. So in short term view, you are just you know uh, fixing everything. Whatever target you have, you assume that that is the target that I need to meet, and you don't look at any other thing. But in the medium term, you have some sort of flexibility because you have a certain time period, and things may change during that time period. For example, assume that you are a production or let's say production planner whose job was to do the supply forecast for next 1 year on January 2020. So that day, what you do, you use the historical methods, historical data and forecasting methods, quantitative methods, and you predict that for next year or so, I will do the actual demand will be this much. That is, we are forecasting this much demand, and we'll plan our things accordingly. But what happened after 2 3 months? COVID came, and then everything was locked down, and things were totally uh, unexpected. So that kind of things can happen, and that will such a calamity will affect your short term goals, but your long term goals can be revised, which was done for every sector during COVID times. So that is where this medium term predictions are there. So what you do, you realize that okay, we have some time to achieve these targets, and if there are some certain disturbances, then you just modify your predictions. So that comes in the medium term. Medium term, you can, again, it varies industry to industry, but you can consider as a 1 year horizon. And then there is long term predictions, which are based on the forecasting techniques that you use. And most major thing is this capacity planning. So uh, when I say long term, it typically means 3 5 10 years, that type of time periods. So capacity planning is basically you estimate that in next 3 to 5 years, or maybe 10 years, depending on the industry, what will be the aggregate demand, or the what will be the, first of all, what will be the growth of this sector. And when you estimate the growth, then based on the current outputs, you estimate that you need to increase the outputs by this much growth percentage to cater the demand, and accordingly you do the capacity planning. Capacity planning can be done for all sorts of this thing. What I mean is, capacity planning is not only for the finished goods; it can be for raw materials, semi-finished goods, etc. For example, if you have a let's say if you have a refinery like Reliance or something. So what you do, the major parameter that is affecting your production or your business is the international crude oil prices. So you need to always look out for cheaper options where you get the oil cheaply. So then you can take some sort of guess that in some coming 3 to 5 years, maybe this US China relations will calm down, and this Russia will also come into the international gambit, and then the Russian oil will become cheaper. This is just an example. I'm not sure about these things, and nobody can. So therefore, the chances of therefore actually the long-term predictions are quite difficult. You need experts relative to the short-term predictions, and there is a high risk also of potential damage to your business if your long-term predictions go wrong. Classic example is Nokia phone. If you remember, some 10 years or 15 years back, the whole Indian market of mobile phones was occupied by Nokia brand, but during the course of time they refused to accept the Android operating system and they decided they'll go with their own, and that's where they made a mistake. And in the long run, today hardly there is any Nokia model that I've seen around for a long time. So that is where their long-term planning went wrong, and that's why their business suffered. So the risk of your business getting hurt because of mistake in long-term predictions is quite high, and therefore one needs to be very careful for it regarding it. So then, yeah, so one question that I'll just read it out because I just told you. The question is long-term forecasts are done for. Option A is scheduling, then controlling, then capacity planning, and then all of this. So basically, the answer is capacity planning, which is right in front of you here. And one more question we'll take, which is related to these things, so that we can move on to the next topic. The question is forecasting of manufactured goods is in the form of, yeah, first option, raw material, semi-finished goods. You have set third option of finished goods, and fourth option is all of the above. Yeah, so basically I think I touched upon this topic some time back. So when you say forecasting, it does not necessarily mean that you'll forecast for only how much goods you need to produce. You need to also forecast that for producing this much amount of goods, how much raw material I'll need to purchase, from where it will be purchased, at what cost it should be purchased. So all those things come under forecasting only. So forecasting is a quite broad term. It has a huge ambit. So you need to forecast for everything, and there are dedicated people in good organizations to do. For example, for a particular product segment, there will be a person who will be responsible for doing only raw material forecasting. Then there will be one person who is responsible for maybe finished goods forecasting, and they actually work in a team, and therefore due to their mutual cooperation, they come out with the numbers that are practically feasible and beneficial for your business. So therefore, the correct option for this question should be all of the above, because you need to forecast for everything. You can't just forecast for product finished goods uh, and leave the raw material side blank, because then how will you make the finished goods? So that is how it goes. So now I think there is enough of uh, this thing, introductory things that we have discussed. Let me just check if I have missed something here. If not, then we'll go next. Yeah, how should I say? Uh, I mean, this is one of the common. One second. Yeah, so forecasting is highly dependent on nature of the industry under consideration. So what I mean by this is uh, examples. I can give some examples. Let's say cyclical businesses. So when I say cyclical businesses, that means there are some category of businesses which are cyclical. For example, production of ice cream. So everybody knows uh, that ice creams are produced by uh, companies majorly to cater summer season demands. Hardly anybody eats ice creams in winter as well as rainy season. I'm talking about Indian context. There will be some sale. It's not like the sales will go to zero. But if you compare, let's say, for such cyclical businesses, if you plot uh, demand versus time, let's say for a year, then what will happen? And let's say we are talking about ice cream uh, industry. In like there are multiple examples of cyclical businesses, but let's say we are talking about one of them, which is ice cream industry. So what happens? Let's say if this is Jan, uh, April, uh, July, then actually I should take 4 months, right? Or maybe 3 months, 4 quarters. So Jan, Feb, March, April, May, June, July, August, September, and then again you'll have next year's Jan. So let's say this is previous year, let's say Jan 22, April 22, and this will be again next year Jan 23. So now, if I ask you, uh, for example, if this is you are a demand planner or forecasting planner, let's say that is if that is the term that you use for an ice cream industry. For example, this Magnum, famous brand Magnum is there. There are other brands also. Arun is there. Actually, there are quite local players also in this industry, so let's not go there. But let's stick with some brand and let us see if you are a forecast planner for this industry, what you will do. So as far as I can foresee, uh, the summer season starts from, let's say, December end or January. It goes till May, let's say, conservatively speaking. Sometimes it can end early, sometimes it can go above May also. So for this much time, from Jan to, let's say, April, May, the demand will be quite high, right? And I'm assuming it will be more or less stable. But practically speaking, it should be somewhat going up initially, and then it should saturate somewhere. And then what happens? At the end of May, rainy season comes, flu season starts. So there, your demand will drastically go down. And in winter, I think it should be the minimum demand. And again, as your one second, as your next year summer picks up, it should be going like this, right? So this makes sense, right? I am just assuming that the demand reaches the previous values. It can go more and it can go less also, depending on which business this is. So this is typical example of a cyclical business. There, in cyclical businesses, the disadvantage is that your this thing will not be constant. Your demand, it will be high for a certain period of time and then it will be low, something like that. But then there are some businesses like what we call them as a secular growth businesses. Uh, for example, uh, typical example could be this mm, fast moving consumer goods. So maybe you can take an example of soaps. So if you're a plant owner which manufactures bathing soap or toilet soap, your demand will not go down or up because of particular reason. So your demand will be more or less like this. It will be always going up. The reason being, uh, whether it is summer or winter or any season, people will take bath, right? So they will need soap, shampoo, hand wash, face cream, face wash, uh, even this, what you use, Surf Excel, Rin, those type of. One good example can be cigarettes. So cigarette manufacturing companies also don't suffer from the demand slowdown ever. So therefore, if you are a forecast planner, it will be better if you go into the secular growth business sector rather than cyclical cyclical sector, because in cyclical sector the forecasting is slightly difficult. So I think this is more or less the theory that you should know about forecasting. We'll talk about different methods now. So let's go there. We'll start with, like, let's say, different methods for forecasting of established products. We are not talking about new or recently introduced products in the market, because as I said earlier, you can't use many scientific techniques for these because they don't have enough historical data. So we are talking about established products, and first method, which is by its name itself, is naive method. So naive method is basically uh, okay. Before I'll talk to that, we'll just fix our nomenclature because it will be used for all the methods going forward. So when I say D, I mean, or maybe we can stick to the nomenclature used by sir. When I say A, I mean actual demand, okay? And when I say F, it is forecast of demand. And when I say this is like subscripts, when I use subscript T, that means current time period. It can be month, year, or whatever. And when I say T minus 1, that means previous time period, okay? You might be knowing this. I am just clarifying for someone who doesn't. So therefore, naive method, what it does, we'll come back to naive method. What it does is it assumes that forecasts for next time period will be equal to the actual demand for current time period. So one can argue that how can this method work? It is whatever demand you are currently having, you are assuming that it will be same for the next time period. Let's say we are talking about 1 month. So you are basically saying whatever demand I had in this month, I will have same demand in the next month. So there is a catch here. This is actually quite simple method. You don't need to know any mathematics. But one point that you should know is this will work up to a certain level for secular or constant demand industry or business. So if there is a business who is rapidly growing, this method will give you a very wrong forecast, okay? So don't use it there. If you have a cyclical business like ice cream making or sweater production plant or raincoat manufacturing or cold cream production or sunscreen production, or maybe the hats that we use. So if you have that type of cyclical businesses, this will not give you correct forecast. If you have secular growth business, which I showed you, like this continuously increasing growth or demand, there also this will not help. This will help for certain businesses where the historical data shows that uh, your demand more or less fluctuates around a certain constant level. So there you can get good results using this method. So if you ask me what is the example of such a industry, so maybe I mean it's actually quite difficult to find. I mean, see, if any industry is doing production, their objective is always to increase their business, right? So usually what they do, they plan for, let's say, 5% increase in the demand for next quarter, or let's say 5% demand increase in the next year. But there are certain businesses which are saturated. For example, let's say you have a workshop, uh, you have lathe machines and CNC machines. So you are catering to certain companies who needs finished goods from your workshop. So whatever machines you have observed that for past 1 or 2 years, or maybe 5 6 years, these machines are working at capacity of 80%. 20% downtime is there for, let's say, maintenance and other things. But more or less this business is saturated, and you'll get only 80% efficiency. And in that case, you don't need any mathematics to forecast, right? What you can do is you can just assume that whatever happened last month, this will happen more or less next month also. Things will change if you install new machines, or some of your machines are not working properly. Then your demand will not be like constant, it will be changing, right? So this naive method is not that bad. For some industries it can work, but it will be very small set of industries. Then there is something called as simple average forecasting. Again, this method, as the name suggests, in this method, what you do, you take a historical data, and what you do, you take a simple average. And for example, uh, we'll take this one example, and we'll use it for you know we'll use the same example for these 2 3 types of forecasting techniques, because then you'll see the difference. So let's take this example. So we have certain period here and the demand forecast. Okay, I should do this with it. So our this thing says demand we represent by A and forecast F. So we have this data Jan, Feb, March, April, May. So you have data of 5 months, and the demand is, let's say these are the number of units. We don't know what units are these, but let's say these are the number of units. Now the previous method, which is the naive method, what by like as per naive method, and the question is, we need to predict the we need to do the forecasting for this thing. Let's say June month, what is the forecast? So by naive method, uh, what you say is whatever previous month's actual demand was there, this will be forecast for you. So 35 will become, I'll not put it here, I'll say FT of June will be 35 because in May it was 35. Then there is this method which is called as simple average forecasting. So here what you do, I'll just use this short form, simple average forecasting. So as per simple average forecasting, your FT will be summation of all the previous I should not say, because see, using this subscript it will be wrong. How should I put? I'll not use subscript, I'll just write it this way so that you'll not get confused. So whatever previous time step information you have, you take that data and divide it by the number of periods that you want to use. So if you do that, this will be summation of all previous 5 months, 25, 15, 20, 25 divided by 5. You can take previous 10 months data also if you have, but here we have only 5 months, so we are taking that. So can somebody help me with the calculation? Ganesh or Ilham? 35 plus 15 will be 50, 70. And this is 50, 70, 50, 120 by 5. So that will be 120 by 5 will be 24. So this is the demand for June according to SAF. Let's say this naive method will put subscript naive here, superscript, and for simple average forecasting we'll put SAF. The reason I'm trying to do this is because we can compare later key and yeah, the actual demand for the June that came out to be was 20. So this actual demand will help us in keeping track of whatever error that we make in our prediction, right? So okay, we used simple average and we did the forecasting. We got 24 as the forecast. Now there is one more method which is again see, one thing here you should note about the simple average forecasting is you are considering all of the previous actual demands equally while taking the average. So you are assuming that whatever the importance of the demand was in May, the January demand is also same equally important. In reality, it doesn't work that way, but for this method, you assume it. Then you go and you do moving averages. One second. Third method is moving average method. Let's say we'll use short form MAM for this. So in this, what they do, they say they assume that see all of the previous data is not important because that data is outdated now. Our company is moving in a different direction. We are having different increased plant capacity, or maybe we are penetrating in the different unexplored markets. So we are growing faster. So we don't need to consider old data. We'll just consider last 2-3 months data and we'll forecast based on that. So if you take 3 months data, last 3 months data is the important data, then you basically take let's say FT June using moving average method. So you don't consider old data, you just consider 3 months data, which is May, April, March. So that will be 35 plus 25 plus 15 by 3. So now one can argue what is the difference between this moving average and simple average. They are all taking average only, right, in the end. But the problem, the difference is in simple average, you are giving importance to all of the previous data. Here, you are giving equal importance to the recent data. Here, I can write this way also, right? 0 into 20, 0 into 25. So 20 and 25 are February and January demand. So basically what you are saying here is I don't care about January, February because that is old data. I am moving and calculating the moving average. So that's how it goes. Then what will be the answer? 35, 15, 50 divided by 75 by 3. I think that is 25 only. So this is moving average. Then there is uh, something called as weighted moving average. So what you say, see, in this moving average method, you assumed equal importance for last 3 months. But if you go for weighted moving average, what you say that the 3 month old data is also not important that much. The last month data is very important for me. So I'll give more importance to that. We'll use this short form for this. So what you basically say that see last 3 years, 3 months data was March, April, May, right? So these were your months used for uh, moving average calculation also. So here you think that this data, this month was important for me, whereas April month was okay, and May month is too old for me. I don't care about May month, March month. So then what happens? The you basically instead of taking simple average, you end up taking weighted average. I hope everybody knows what weighted average means. So what weighted average means is you'll give more importance to the May data, which will be 60% into the actual value of 35. Then this April data, which will be I think 25. And then this March data, which is not that important for this prediction, will be 15. So if you do that, what happens? This last will be 1.5. This will be 7.5. And this guy will be, I think, 10.8 or something. 18, 6 into 35 or 210. So 0.6 into 35, so 21. So total will be 21 plus 9, 30. Okay. So this is the fourth method, and I think there is one more method. Which is called as exponential smoothing method. And there is one more which is okay, the offshoot of this method, which is okay. Ganesh has raised his hand. Ganesh, go ahead. Ganesh, can you hear me?
Sir, good evening, sir.
Yeah, good evening, Ganesh.
Yeah, so after all this, we are using these four types of methods for forecasting.
Hmm.
So we are getting different type of variables, right?
Different type of forecasts. Yes.
Yeah, forecast for the month of June.
Yes.
So how could we have this particular actual, constant number where we can choose this particular method to have in our company?
Actually, your voice broke up in between. So as far as I could hear, your question is out of all these methods, which method is better or which method gives the good estimation, right? Is that what you're asking?
A similar kind, sir. I'm asking that. So after all, we are doing these four methods. We are getting
Uh,
different type of forecast values.
okay.
So for one particular table.
Uh,
So
okay.
which one is the better one to consider to have this to have an absolute value for forecasting?
Yeah, I'll come to that because see, you can't say that one method is better and one method is not better. What you have to do? I'll talk about it. Just give me some time, because I'll just introduce these other remaining two methods, and we'll just see the
Yes.
mathematical formulation, and then I'll give some summary in the end. So there maybe you'll have some idea about why we are doing this.
Okay, sir. Okay, sir. Sir, one other thing is that from in the first one, in the simple average method,
Okay.
uh, sorry, naive method, like in you have written 20 in the demand section, demand parameter
Mm-hmm.
for June. How is that came
So
a bit
basically, uh, so when you do forecasting, you don't know this 20. This 20 number, you know, at the end of June. Uh, so these calculations that I'm doing here, we are doing them at the starting of June month. So there you don't know the actual demand. I have given this actual demand because it was mentioned in the question. But for now, you can just neglect this. You just assume that you don't know, because that is why we are doing forecasting, right? Otherwise, if you know the actual demand, there is no need of doing forecasting.
Okay,
So,
sir. Okay, sir.
so for
I
now,
got confused with while you have written that. So
okay. So it's okay. For now, let's forget that 20. We'll go ahead. So we are using some methods and we are predicting something. Okay. So for now, just focus on this method and what it is doing. So I think you have understood this weighted average and all. Now there is one thing called as exponential smoothing. I don't know. Smoothing should be the better word, but okay, we'll go with the class this thing. So here the formula is ft is a function of some alpha. Alpha is a constant number, and 1 minus alpha into ft minus 1. So here one question, we will just digress for some time. See, when you see these type of expressions, you should get the idea that see, I'll just give you the question so that you'll understand what I want to say. And this alpha is called as smoothing coefficient. Okay, it's just a number. You don't know the value of this number, but it's a constant. It is not a variable. So now the question that is asked is, uh, this alpha varies from. So you need to basically take a guess that this alpha value can vary from which point to which point, which value to which value. You have these options. First option says 0 to infinity. Second option says minus infinity to infinity. Third option says 0 to 1. And fourth option says minus infinity to 0. So can one of you, okay, I'll just make it interesting. Uh, minus 1 to 1. Okay. The fourth option I changed it myself because the other three were quite easy. So Ganesh has answered the question, but I want some explanation because see, I mean, it is the question. I think it's not that difficult, but I just want to give you a general uh, answer for these type of questions. You'll face these type of questions not only in this course, but in some other exams also. So what happens? See, first of all, you should be convinced that alpha cannot take infinity or minus infinity, because let's say if alpha can take say alpha can take value of infinity, then what happens, this first term which is alpha into at minus 1, that will go to infinity, right? So your whole thing, your prediction is basically infinity. So that is not practical, right? You cannot have infinite demand for any product. So therefore alpha cannot take infinity, and by same logic alpha cannot take minus infinity, right? Because then you'll have demand which is minus, tending to a very large number which is in negative. So that also doesn't make any sense. So basically The takeaway is alpha must be bounded. So must be bounded in the sense it should have some lower limit and it should have some upper limit. So therefore, this wherever infinity is there, all those options are wrong. So now you are left with C and D. So C and D both have the upper limit of 1, but the lower limit is -1. So uh, let's talk about case D where alpha varies between -1 to +1. So let's say if alpha is -1, what happens? Your ft will become alpha is -1, so minus at minus 1 plus 2 into ft minus 1. I hope this is clear. I'm just putting alpha -1 in this formula that is there. Then what happens? Your ft will become 2ft minus 1 minus a t minus 1, right? I'm just reshuffling the terms here. So now you should understand. I can give you one example in which uh, 1 second, I am getting a call. Just got. Okay, so here, do you see any problem, Ganesh, with this expression? This I am rounding it. Any problem that you see here? Okay, so if you are not answering, I'll make it more clear. Let's say you have got this values. Okay, this relation for your forecast for the current period, which is function of forecast of previous period and actual demand of previous period, right? So let's say previously you forecasted 10 units, but actual demand came out to be 30 units. So now if you put this value in the expression, what you'll get? 2 into 10 minus 30, which is 20 minus 30, which is minus 10. So uh, can your forecast be negative? I mean, it should be always greater than 0, right? So therefore your alpha cannot take negative values also. If it takes negative values, then there may arise a case in which your next forecast is also taking negative value. So therefore alpha cannot take negative value, and therefore alpha can take only positive values, and we limit it to the uh, upper limit is kept as 1, because then you can have some sort of scaling. See, as I told you, alpha cannot be taken as unbounded. It cannot go to plus infinity or minus infinity. So you may ask that, okay, we know that alpha should be greater than 0, but why you are limiting it to 1? That can also be a question, right? And that is a valid question. So the answer is uh, you can take any limit, upper limit for alpha, but we keep it at 1 to make our life simple, because if you have alpha between 0 to 1, and let's say, again I have digressed, but let's say we go back to the previous example where we were calculating ft, right? So let's say we take alpha equal to 0.3, then what it becomes? Your ft becomes alpha into 81, so this is 0.3 into 80 minus 1, and 1 minus alpha is 0.7 into ft minus 1, right? I hope these are clear. I'm just putting alpha value in the expression. So here basically you are giving 30% weightage to actual demand for t minus 1 time period, and you are giving, 1 second, can I copy this? So you are giving here you are giving 70% weightage to forecasted demand. I hope this is making sense to you. So now what happens? This alpha can take any value from 0 to 1. So there is one more question which is very commonly asked. Higher values of alpha. 1 second, I'll just see the actual question. One second. Yeah, so higher value of alpha is preferred when you have 4 options. First, more importance is to be given for recent actual demands. You have second option, when demand data is less noisy. When demand data is stable, I should make it more noise. And fourth option is all of the above. So see, the answer is in front of you only here, because here we have assumed alpha value of 0.3, which means we are giving 30% weightage to the actual demand for previous period and 70% weightage to the forecasted demand. So when I say I want to take higher alpha value, what will happen? This 0.3 will become, let's say, 0.8. Then your FT will become 0.8 into 80 minus 1 plus 0.2 into FT minus 1. So you are giving lesser weightage to your previous forecasts, but you are giving more weightage to the recent demands. So in that case, you are giving more importance to the recent actual demand. So this is correct option. Then second option says demand data is more noisy. That is also correct option, because see, your demand data is not stable. Your data is more noisy. That means there is high fluctuation in your demand data. So there you cannot predict with lower alpha. Lower alpha basically means you will have stable demand. But when you have a noisy or frequently changing demand, you need to take higher value of alpha. So this is option is also correct. Stable demand is not correct, and it is not all of the above. So you need to understand the physical significance of alpha in order to like you can do the maths. Maths is not that difficult here. So I will just leave you with it with this note. Lower alpha, stable demand. Higher alpha, fluctuating demand. So if you can remember this, that is also fine. That is this question. So we have digressed to somewhat other topics. So we'll go back to our this thing. We'll take alpha equal to 0.3 and we'll do the prediction for June month using exponential smoothing method. So that means we'll use this formula, right, which is 0.3 into 1 second. So now what was the actual demand in the previous month, which was I think May month, 35. But now we are stuck here because we need forecast of May month. So that we don't have, right? Now here is the problem. So now we'll have to do the demand for everything. So therefore doing these calculations manually is a pain. What you can do, you can just use a Excel sheet or something, and you can just use, you can do the uh, calculations, because that's recursion Excel will do quite good, right? So that is, I have copied it, but where is this? Okay. Array. It's not coming. I'll try once. If not, then we'll have to do it manually. Okay, it came, but it did not came. क्या हो रहा है? Okay, let's leave it. We'll just do the calculation. So this was Jan, Feb, March. What is going on here? March, April, May, June. So it was 25, 20, 15, 25, 35, right? And this was our actual thing, actual demand. So we'll use 80, and here our forecast. So see, first month you can't do forecast because you don't have any previous data. So now one second. We have this formula, right? 80 minus 1 and FT minus 1. So see, you have to do some sort of forecast for the January month, because otherwise you can't use this formula. So I'll do, I'll use the this method. There is no method because you don't have any previous data. So I'll assume that the demand and actual demand and forecast were same. So now we can proceed, because otherwise you can't proceed, right? So here, since it was same, your forecast will again become same, because you are just multiplying by 0.3 and 0.7 to same number and adding. So it will be 25. Now it will change from now on. So 0.3 into 20, which will be 0.3 into 20 is 6 plus 0.7 into 25. So 0.7 into 25, which is 17.5. So total will be 23.5. Then here 23.5 into 0.7 plus this 15 into 0.3 will be 4.5. So 4.5 plus 16.45, you will get total of 20.95. Then again you do it for May month. See, in escape this because it is a recursion. The whole thing is dependent on each other. It's not independent like moving averages. So mathematically you can look into that. You'll realize. So 20.95 into 0.7 plus 25 into 0.3. So that will be 7.5. So it will be 7.5 plus 20, sorry. Minus 7.5. So this will be 14 point, let's say 7. So 14.7 plus 7.5, you get 22.2. And finally, our thing that we wanted to calculate so long. So here, this ft minus 1 will become 22.2. So into 0.7 plus 0.3 into 35. 0.3 into 35. So total you are getting 26. So here, after doing all these calculations using exponentially smoothing method for June month, we have arrived at 26.04. Okay, so now we'll stop here because there is one more method which is called as exponential smoothing with trend, that you can look into this thing, your class videos, and you'll realize what it is. So I'll just summarize why I was doing these calculations, and Ganesh also asked about this. So, and finally you realize that actual, like you did this forecast, okay, and then you manufactured everything, you did the sales, etc. And at the end of June month, you realize that actual demand for June month was 20. This is, you did not know this about, you did not know this before. When you are doing forecasting, you did not know this 20 number. You came to know after you did the sales. So now you realize that, okay, I have used different methods, but my actual demand is 20. So let us see which method give me the best estimate. So let's make one more table. So we'll just name that method, and we'll give its forecasted value also, ft for June, using that method, and then we'll see how it goes. So first we used naive method, right? So first was naive, which said the forecast for June will be 35. Then we used simple average forecasting, and that gave the value of 24, and moving average gave 25. Moving average method gave 25, and after that we used weighted average, which gave 30. And we used exponential smoothing method as well with alpha of 0.3, and we got 26.04. So now see, actually you needed only 20, and almost all the methods over predicted. So now if you ask me which method was the best one, one thing that I can do is I can just calculate what was the error. And here forecast error we define as AT minus FT. So these are all FT values, and this guy is actually the AT value that we have. So here we will take absolute value because I mean, we don't care about the sign of it, right? If you miss your estimate, it doesn't matter you miss it by plus 10 or minus 10. Both the situations will give you loss in your business, right? Because if you manufacture more than what you need, you'll be penalized by the way of inventory. You need to store the overproduced goods. And in another case, if you underproduce, then your customer will not be satisfied and your customer will go to the competitor. So you lose there also. So therefore, the sign of the error doesn't matter here. The actual value matters. Therefore, we are taking the absolute value, which is given by the mod operator as shown here. So here we'll calculate this. This is called as uh, mean error. So this is also called as mean error. So we'll use ME for that. So what is the mean error? Here it will be 15. Here it is 4, 5, 6. So not 6. Here it is 10. And here 6, 0. So now you have a better idea, right? That out of all these methods, this which method? This method, which is simple average method or simple average forecasting, that gave you the best prediction. So that is how you decide. So now you have reached till June month, right? So what you do for next month, which is July, you do the same process, but use the simple average method. So one more thing I would like to highlight here is why the simple average method was the best method in this example. Because in this example, your demand was more or less stable. So basically, it was hovering between 35 to 15. So this is actually quite stable demand considering 5-6 months of time. So if there was some like in this data, if some value was like 100 instead of 10 or 20, so basically if you are, see here, the spread is from 15 to 35, right? So your demand is varying between 20, 35 minus 15, which is 20 units, right? But if I give you one more data set in which the difference of maximum and minimum value of demand will be, let's say, 200. So there the simple average method will not be correct. There may be some another method which will be suitable for that problem. So there is no fixed set of method for particular problem. You need to try all the methods and see which is giving the better estimate, and that's how you move ahead. Okay. So I think this is okay. Then there is one more method which is called as regression. I'll just see if we can cover it briefly because we are out of time almost. But I think in 5 minutes I'll just give you the idea what it means. So what happens? There is something called as trend in demand. So for example, for certain businesses which are, as I said earlier, secular businesses, so their growth is more or less stable with respect to time. So if you are in certain, let's say, fast moving consumer goods, so there you'll have a always positive trend with respect to demand. So demand will be always increasing because you are catering to a large population, and you are producing a product which is getting consumed on a regular basis. But it will be not actually this straight line, because in some cases the actual demand may come like this for this month. In some other case, it will be slightly higher. In some other case, again, it will be slightly lower. But more or less, you realize that with respect to time, it is going up, and you can fit a straight line for predicting this demand going forward. So this line is called as trend line. Sorry. So trend line, and its equation is like any line has equation which is y equal to mx plus c or ax plus b, whatever you want to call. So this is the slope and this is the intercept. So now I mean what I trying to say is, if you want to define any line, you need two values. One is the slope and another one is its this thing intercept on the y-axis. So, and here what we do, this y is our predicted value. So subscript p is a prediction, or maybe you can use f, because we are not doing prediction, we are doing forecasting, right? So subscript p says the y value which is forecasted, and there will be one y value which is actual, right? So this ya is actual demand. Understood, no? So what happens? There will be always some difference between yf and ya. So this is what we call as error, right? We talked about this also. So here, if you defined error like this, and if you do it as a square, so this is called as squared error. Squared error loss. These are just mathematical terms. If you don't know this, that is also fine. You can just Google and see. Since we don't have much time here, I'm just introducing you to these terms. So now your objective is to find M and C, right? So you have some data. So this is your y-axis, and this is your x-axis. Time is your x-axis, and demand is your y-axis. So you'll have a table in which you'll have all the x-axis values and y-axis values, right? Something like this. So you'll have time data, which is x value, and you'll have demand data, which will be y. Our variable is y here, right? And this time can be like earlier example, Jan, Feb, March. So basically, we can give them number as 1, 2, 3. Since we are doing maths, we have to number them, right? So these are equal intervals, no? So we can give them number 1, 2, 3. And let's say you have some demands like 20, 25, 40. See, here demand will always be going up, right? I mean, it should not happen that after 20 you are coming back to 10. So then it is not a secular growth. There will be fluctuations there. So trend line is suitable if the demand is continuously increasing with respect to time. If it is fluctuating, then trend line may not be a better estimate. There you'll have to use the earlier methods that we used, or there are some methods which are particularly for seasonal forecasting. Professor also touched upon that somewhat, but for example, this seasonal index and other things, we don't have enough time to go into that, so I'll skip that part. But here we are talking about a case where your demand is more or less increasing with respect to time. So there you can do some mathematical calculation. So I mean, what is done is, let's say your squared error loss, let's say it is L. So you have L, which is yf minus ya square, right? And it will be summation of all the points that you have in your data set. So if you just put your yf is mx plus c, right? So you will have mx plus c minus ya square. So what you do? You take derivative of loss with respect to uh, this. With respect to, one second, you take derivative twice is what I remember. Let me just confirm this. Otherwise, yeah. So you take the derivative with respect to slope because you want to find the slope, right? So that is the unknown. So you take derivative there and equate it to 0. So that will give you a solution. So that will just equal to equating summation to, I am assuming that you know this differentiation and all. And since you are differentiating with respect to m, you will get 1x here. So this will be 0. And you will get one more solution by doing the derivation with respect to the intercept. Here you will get similar to this uh, mx plus c minus ya. Here there will be no multiplication because c is a constant. So now here you have two equations, two unknowns. Then you solve them and you get a particular matrix like this. I'm sorry, I'm going slightly faster here because we don't have time. But this is quite standard. You can look it up. You'll get certain uh, matrix like this. And here you will have your M, C, and here you'll have summation of yi, which is your ya actually, yai, and you'll have summation of xi, yai. So what you do basically, one second, I'll just write it slightly better. Yeah, so what you do, you just take uh, sum of these values. This will be your sum of summation xi. You take the sum of this value. This will be your summation yi, and these are the values that they are represented here. So this will be your yai. And what you do, you create one more column in which you write x square values and take sum of them. So that will become your xi square. So like that you add. So then you will take one more column which is xy, and you calculate it for all the values and take summation. That will be your xi yai. So that's how you calculate all these values and you put it in this matrix form. N is the total number of uh, sample points. So in this data, in this table, however, let's say you have 10 months data, that will be your N, and that's how you calculate. And then you get the M and C. So basically you get the trend line equation, which is YF is MX plus C, right? So now you know M and C. So then if anybody comes and asks you at what particular X, what should be the forecast for the demand, you can just use the simple calculation and do the maths. So I think I don't have time to take one more example on this, but this is before we close, there is something called as we'll stop after this. There is something called as correlation factor in this method only. So basically, here the unknowns are M and C, but if you do some mathematical calculations more, uh, I mean, you'll get this correlation factor, which is given by quite a tedious formula. I'll just, for the sake of completeness, I'll just mention it here. Uh, this formula looks scary, but it's not that scary. It's just a mathematically intensive formula. That's it. But if you don't, there is no need to mug up this or something. I just want to explain one thing that is relevant to this. I think I should not have written this formula also because it's quite scary for me also. Anyway, so this is the formula, but no need to remember this because it's not useful anywhere. What you need to remember is this when I say this correlation coefficient, the correlation coefficient can take positive values, it can take negative values also. Okay, but okay, 1 second. If R, if you do this mathematical calculation and if your R comes out to be 1, that means strong positive correlation between X and Y. So what this means is, if you take all your X and Y points and if you take them as a scatter plot like this, something like this, you'll have a certain number of points, right? And if you do this trend line fitting, you'll end up with a trend line which will have 45-degree slope. So your M will be tan 45, which is more or less 1. So when your R is 1, essentially it means your the correlation between X and Y is quite strong, and that means you have a good curve fit. Like you can estimate the values in a confidently manner. So in the same way, if R is -1, the slope will be -45. So in that case, if R is -1, it should somewhat look like this. Yeah, something like this. This will be 45. So here your M will be -1 because of tan -45. So there is a strong negative correlation between your data if R means -1. So as the name suggests, correlation factor, you should remember this, that because I saw one question which was quite interesting. There it was asked that question, the linear regression equation for R equal to 1 is. So basically there are 4 options: y equal to a plus x. Oh by sir, this got pasted here, huh? It was not pasted there, it was pasted somewhere down the line. I don't know why. So these are the 4 options, and y equal to a minus 2x. So if you just see this question, you'll not get any idea, because first of all you should know what is the correlation factor. And then you know that when it is 1, that means the slope is 45. Let's say the theta is 45, this angle, and therefore the slope will be tan theta, which is 1, and therefore there is only one option correct, which is A option. If this R was -1, you'll get something like that. And if this R is let's say half or something, then you'll get tan 30 around. So there you might end up with some other M value. So this is it. I think I don't have time for covering that seasonal thing, but just remember that when you are having seasonal demand for a seasonal business, there you use a seasonality index, which is again estimated based on the previous data. So the procedure was discussed by professor, so you can go through that and solve some problems that will give you some confidence. Okay, so shall we stop now? It's already 8:40. We'll stop and we'll meet next Tuesday. Anybody wants to ask something? Okay, Ganesh said thank you. Thank you, Ganesh. Ilham and Sanjay. Sanjay also joined later. So shall we close then if nobody has doubts? I'll wait for 1 minute, or let's say 10-15 seconds. Ilham you raised hand. Okay. What is
Sir,
the
will
question?
you once
Yes.
again explain moving average method?
Pardon. I could not catch you completely. What did you say?
Moving average method once more, please.
Okay. So moving average, basically, see, you have demand. You will have a lot of data, right? But what happens? Your old data is not relevant sometimes. So instead of relying on old data, what you decide that I'll do my forecasting based on only last 4 or 5 months. Because, for example, if it is, let's say, COVID happened, right? So in that year, all your actual demand will be almost negligible, right? Because everything was shut down. So you cannot do your forecasting based on that COVID time data, right? Because that will be wrong, na? Your actual demand will be very high. So what you do, you neglect that COVID wala part, and after COVID lockdown was removed, for next 4 5 months you will have an actual data, right? Actual demand data. So you do the forecasting based on the actual data. You discard the old data which may be giving you wrong forecast. So that's how it goes. And moving average, as the name moving suggests, you will take an average of certain time periods, and that will keep on shifting to the next. So here for June month we used May, April and March, right? But let's say you did the June forecasting and now you want to do the July. So for July you will use June, May and April data. Understood?
Sir, we are taking always 3 months before, past 3 months only.
No, that is your choice. Here I took 3 months. If you are not comfortable with 3 months, you can take 4, 5, 6. Depends. It is not a fixed rule. It is your choice.
Okay, sir, thank you.
Okay, thank you. Okay, then shall we break for today? I think we can discuss if anything is there next time. Okay, then I'll stop the recording and thank you for attending and good night.